container folder of the practical. So I know I told everyone to install VS Code. VS Code is a code editor that also has a terminal in it. So I'm using WebStorm actually. So I'm in the multi-container folder. So we have the backend directory, front-end directory, and the web server directory. So I showed an image of the kind of application we are to build, the web application we are to build. So we have the web server here. We have the backend, the front end, and the database. So we are trying to put all this application into Docker containers. So to build containers, we need to first build the blueprint of that container, which is the Docker image. So I was trying to show you how to build Docker image, and one of the participants helped in building the Docker image for the front-end application. So front-end is what the user sees when you type a URL in your browser. So this is a web application. So the front-end is what the user sees when you type the URL into the browser. So from what it did, as I said, to create a Docker image, you first need a base image. And the base image here is Node version 12, built on top of the Alpine Ubuntu image. The next thing is to specify the working directory, which is the /app. So in this current working directory, we have a package.json. And in the Node.js world, this could also be Maven. It could be any dependency used in any programming language. We are packaging a React application here. So the package.json has all the dependencies needed to run this application. So the first thing we are doing is to copy the package.json into the current working directory of the container to be built container. So dot always specify the current working directory. So it means copy this into the app directory. The next is a command run. One is used to run commands on top of the base image. So now this run is running npm install. In the Node.js world, npm install is used to install all dependencies of that application. So this will go into the package.json file, look for the variable called dependencies, and install everything on top of the base image, Node 12. So after this, we'll have an image with all the dependency installed. The next thing is that for an application, you have to copy all the code needed to execute or to run the application. And that's what the next command does on line 9. It copies all these files you see here in the front-end directory. It copies this. It skips this because we included this in the Docker ignore. It copies the public. It copies the source. Everything it copies into the working directory of the image, which is /app. After that, the expose command, as I said before, is to expose a port. So the React development server listens on port 3000. So it exposes, it tells Docker image that this port 3000 needs to be exposed so that people can connect to it, so that it can receive traffic requests. So the final thing of a Docker file should be this command. You know, when we were running the Ubuntu image, we just ran it. We didn't specify any command. That's because it has a default command. So the CMD here is the default command of this container, of this image. So it will start This means npm start. This will start the React development server and make it ready to receive requests from users. So again, I will try to build the container. After I build it, I will run the container. So this is the Docker file. To build the image from the Docker file, so we type docker build -t to give name to the image. React front end. Please, who knows what React is in the web development world? Okay, so it's a front end framework used to create web applications. Then after we specify the name, we have to specify the context. Context is the directory where all this and copy will be done from, or where it will pick the Docker file. So here we are, we have to be in the correct folder. So this is the command. So this command will look for a Docker file in this directory frontend, which is this file, and run each of these commands. First, it will get the base image. It will create this directory. It will copy the package.json. It will install all the dependency. It will copy the REST files to expose this port and set the default start command for this Docker file, the Docker image, I mean. So we run this. Yes. So it's a new link. So this is the new link for the practical. So just change the last word to this HPC_course. Tell me when you're done. Are you done? Have you gotten the link? Okay. So let's scroll and read the output information of the Docker build. So we can see the first step from Docker. It first gets this image from Docker Hub. Then it transfers any current context. Then the next step, which is our next command, work dir. So it creates the current working directory number 2. Can you see my mouse cursor? Please, can you see my mouse cursor? So the next step, which is this here, it copies the package.json into the image. Then it installs all the dependencies. Then it copies every other files in the working directory. And it creates the image, writes an image. And it names the image React Frontend, which was the name I gave it. So now that we have the image, the next thing is to run the image. So let's run the image. So we run it with doc docker run. We have to publish the port. Should be, let's give it 4,000 this time. So the first port is the port we want to open on our host machine. The next port is the port that the application uses. So here, you can see it's port 3000. Any other commands? Do we specify any other commands? So the last thing is the image name, which is React front end. So he runs it in the background. So if I add a -d here, I won't see all the output information it's about to do. So it just runs the application in the background, but this is to print all the application information on the terminal. That's what the -d run in the background. Yeah, immediately I stop the application, the --rm completely deletes the container. Okay, did I forget anything? Publish the port, docker run, publish the port, then the name of the image. So now, this is the start command. So it is done, starting. So here we specified npm start. If you go to the package.json, we will see what npm start does. So npm starts this script, React script start. So you can see that is the first thing that is run. That is because we specified that command in our Docker file. So now we have this React application running on localhost 3000 in the container, but we have mapped it to 4,000 on our system. So let's visit localhost. So this is the React application. So we went through the step from creating the Docker file, building the image, running the image, and viewing the output of the image. So this wouldn't work right now because the backend is not set up. The database and the backend is not set up. So any questions at this point? Any questions? Please come again. So this is the Docker run. Okay, Docker run. Yes. Yeah. So in the slide, I told us we'll be Dockerizing multiple services. We'll be Dockerizing these services. So we have our web server, we will have our backend application, we have our front-end application, and we have our Postgres database. Please, who can tell me the first application or the first service we should deploy? Which one is the first one we should deploy? Should we deploy the backend first, database first, the web server first, or the front end. In database, they are very correct because the database, the backend needs the database to work. So so now we don't need to create a Docker file for Postgres because it's already available on Docker Hub. An organization or someone has already done that job for us. It's just for us to use it. So we'll be creating the command for running the Postgres database. So I have it here. Okay, first thing, we learned about networks, communication. So networks helped us to communicate between different containers. It's the best way to communicate, though we can always open a port. But the best way to communicate between containers is by using networks, Docker networks. And to create a Docker network, we use the Docker network create command. So we will do that now. So, but first, let me queue. So Docker run -p, the 4000 is the port on the host, your machine. The 3000 is the port, the application, the container port, the application, the port, the application on, and the name of the image. Yes. No, after you create the image, you don't have to be in that. You want to create the image, you have to be, or you specify the path to the Docker file. Yes. After you create the Docker file, you build. After you build, you specify the name of the image, which is React frontend in my case. Then you create the container by using Docker run. Create and start. So I'm trying to remove a container. If you want to remove a container, if you don't specify a name, you have to list all running containers. And to list all running containers, you use Docker PS. So this will list all running containers on your system. So we'll pick either the name or the container ID. So Docker rm-f, then the container ID. So this removes that container. You can check this. So you can see we don't have that container anymore. So the first thing you want to do is to create a network. So this application, I have not described it. So it's an application for managing tags. You can create tags, you can delete tags, you can update tags, you can view tags. Just normal CRUD, a normal basic CRUD application. So first, I want to create the network to allow communication between the different containers. So I'm picking this command. We can also try this. Please, let's try this on our various laptops. Not just watching me. When you try it, you also gain one thing or two. It also sticks to the mind, to the brain. So I'm creating the network now. So to see if it has been created, we can list the networks. So we can see the network I have just created. So this allows each container to access other containers just by the name of the container. So when my backend application wants to access the database, I can just specify the name I gave to the database container as the host name. So we will see this very soon. So the next thing I'm running is my database. And let's go through the commands. We can see Docker run. Here we are specifying the name, PostgreSDB. So this is the name we'll use to connect to the database. Here we are specifying environment variable. In a production settings, this is not the way we specify our environment variables. /e. We specify it in a config file. Then we are specifying volumes. You know, I talked about volumes. Volumes are the way you store, persist data with containers. Containers on their own cannot keep data. They cannot persist data. You need to attach a volume, a map, a volume from your host system into the container. So yeah, I'm mapping this directory from my host system to this directory. So it's important to specify this directory because this is the directory Postgres actually stores the data you save in the database. It's important to specify this directory. So I'm specifying the --rm, meaning if I close or stop this container, immediately remove and delete the container. Then the next one, I'm specifying the network, which is very important for communication between containers. All the containers wanting to communicate must all use this network, must all come under this network. Then I'm specifying more environment variables, the user of the database name.
So I want you to come back on the network. I see where the drive, I see a column here. When you say you type network ls and it said bridge, host, and bridge. Can you explain it to us, please?
Okay.
Yes. Okay.
I just know how to use it. I have responded so. I have no idea of the network architecture and all this. It's not my area. So on the question he asked, I have no idea because I'm not a system administrator. I'm a software engineer. So I'm also learning. Yeah. Yep. And that means your Docker daemon.
I'm getting a flag here. It's saying my Docker daemon is not running. Docker daemon is.
And did you install it correctly? No. Did you install Docker Desktop correctly? Yes, on your system. Okay. Did it work for you?
That's the response.
That means the background service is not working.
Okay.
Yeah. So before we go on, it would be nice if Someone can also try to explain this thing to us, the type of network it's using the driver. Does anyone have idea? If anyone has idea, it would be nice to share with the class. So I'm more of a software engineer. I know how to use it. Yeah. So, but the thing is that when you go into much more higher abstractions, you don't actually create this thing. Let's say you have a microservice. You know, microservices are loosely coupled applications of hundreds of services. You can't create a network for everything. You have to find a way to automate it. And that's where you use something like Docker Compose or something higher like Kubernetes. So Kubernetes manages all these things for you rather than you creating it yourself. So in Docker Compose, you don't even create this network by yourself. It's created for you. Everything is managed by Docker Compose. So we get to Docker Compose after this. If it doesn't work, then maybe you have to. So let's go on. So here we are still specifying environment variables. PostgreSDB, the name of the database you want it to create. And finally, Postgres, the name of the image. So now we are trying to create and start the container of Postgres database. So number one thing, you can see how cumbersome this is. We have to specify a lot of commands. So if you have like a microservice that will use like 10 databases, it can easily get complicated. So this is one downside of just using only Docker. We will see a much more elegant way of running this kind of services later. So we create the database. So this is up and running, ready to receive connections. So the next thing we run is the backend service. So we first have to build a Docker file. So from that Docker file, build an image. And from the image, we create and start. We run the image to run the database, to start the database service. So for the database, we use Nest.js. I don't know, does anyone know Nest.js here? It's a JavaScript framework also built from Node.js. Okay, thank you. So the first thing we do is to go into the directory. So, okay. Thank you.
Just I have an error here. Yeah.
What's
When
the
I
error?
try to run the error response from daemon. Make directory, program files, git custom access is denied.
Are you using Ubuntu or Windows?
Windows.
You shouldn't have access is denied error.
there something I was supposed to change, like before running the database?
Yes. Okay. I know what is going on.
Mm-hmm.
You have to create this directory before mounting it, because Docker is trying to make a directory from that, and you don't have access to do that.
Okay.
Maybe you are running the Docker without enough. We are running without enough permission.
Okay. So I should
So our next plan is to build the Docker image for the backend application. So I already have a backend image. So you can see every Docker file needs to have a base image. And yeah, who can tell me what the base image is? Someone, anybody? Please help me out. What's the base image for in this Docker file? The base image. It's very simple. No. Just pronounce the full name of the base image. Anyone can help. The base image in this Docker file. No problem, I'll show it. So as I said before, every Docker file needs to have a base image on top which subsequent commands will be installed on. So the from is used to specify the base image. So this is the base image, node:14.15.4. This is the base image. This is the version of Node.js. And this is built on top of Alpine 3.1. So now you know the base image. Yeah. So let me give you another test. Please, what is the base image in this Docker file? 1 point, yeah, thank you very much. So the from command always specifies the base image. Yeah. So this is an environment variable used by the CLI. So as I said, workdir specify the working directory. So every subsequent command is run based on this current working directory /app. So we copy the package.json into the current working directory /app. We run npm install. We expose the port. We copy all subsequent files into the current working directory, which is /app. Then we run subsequent command, which is npm run build. So this will take all the code that has been copied from the directory. This directory. It will take all the code and build it and spit it out in a dist folder. Then the start command. Every Docker file has a start command also. Every Docker file has a start command. So this is the command that is executed when you run the Docker file, when you are trying to run the image. So any questions from this point? Any questions? I think I have questions for the people sleeping.
attend. It's not a global question now. But since I keep going,
Did you resolve it? Okay, no, that's not the name though. That's a bind mount. Because actually you don't know the location where it's created. You know, Docker has its own virtual machine internal, so he creates it in its own internal virtual machine.
okay.
So access to that is not yours.
Okay, so do we have the full path of the?
So I guess
Okay, what are we at?
let me finish running then see the results. Okay, I want to ask my own question. Can someone come and help me create the Docker image, build the Docker image for this file? I need a volunteer. Anybody? Okay, please. Thank you very much. Okay. To build the Docker image from this Docker file. So I've helped you to be in the directory. So we have this Docker file. We want to build the image. So Docker, yeah. Okay, my keyboard layout. This is it. Okay, you got it. Hmm? It's a German keyboard. Yeah. Okay, use because we'll use it for the networks. Why is this thing so okay? Yeah, I just send the answer. So use this name. Oh, careful. Hold on.
Is it okay over there? Do you delete anything?
Let me check. Hold on. Hold on. Hold on. Yeah, I don't think you did anything. Yeah.
Okay, can you go to the map?
Okay, you deleted something. Okay, one more. So this name. Okay, you can just. Oh, hold on. Yeah. So you specify the context also. Are you in the directory of the? So yeah, that's the directory. Yeah, it's good. So you also help me create and start the container. So let me say something. So this backend application, we need environment variable like the host name, the port, and okay, let's just check the configuration file. So you need the host name, the port, though we can leave the port, the user and the password and the database name. So you just try to specify environment variables. So you create them as environment variables. Let me go on. Okay, so you can start with the port mapping. Or okay, start with the environment --env. Yes, yeah. Okay, give it the name you want. Tax management API. So let's start with the with the port mapping. So this application listings on port 4000. So we are mapping the port. Okay, good. On our host machine. So the first port is the port on our host machine. To the port the application is listening on, which is 4000. Okay. And we specify environment variables. Let me open it so you know the names to use. So you can start with the host. It has to be this name. Oh, hold on. Okay. So Postgres host. So now, because we are using a network, we can just use the name of the database as the host. So Docker does its magic behind the scene and notice, okay, this person is trying to connect to Postgres. Postgres uses the name as their IP to connect to the Postgres. The name of the container, yes. Yes. Yeah, that's Docker does, yeah. So, okay, let's check the name of let's just Docker PS. So if we scroll up, and that's the image. So name, PostgresDB. So no, you have to specify equal to. So the next, you can let's leave the port because it's already hard coded. You have to use the dash dash env again, yeah, each time. Postgres user. Equal to. So I named it test underscore user. Then the next is, hold on, the password. Equal to my secret password. Just my secret password, no spaces. My and the last is the database. So PG database. No. Yep. No underscore. So you. No underscore. So tax management. No, full the full. Yeah. So any other thing that we should specify? Yeah. Thank you. The network. So dash dash network. So we can check also just to be sure. Docker network ls. So then the last will be the image name. Okay. No, let's run it in a full. So now we have the Docker file. We are trying to build an image from the Docker file. And the command to build it is what he has helped us with. We start with Docker. Okay. Okay, we've built the Docker file too, and we've made it a, we call this tax management underscore API image. Now we are trying to create and start the container with Docker run. So we first specify the name of the container, and this is essential because if any other container wants to connect to this container, it uses this, Docker uses this as the IP or the URL or the host name to connect to this container. Then we have the port mapping. This application listens on port 4000 and we are mapping it to port 4000. So this specifies the port on your host machine and the other one specifies the port in the container. Then our application requires several environment variables to run. We start with the Postgres host. That's the host name to use to connect to the database, the user, the password, my secret password, and the database. Normally, in a production environment, you don't just specify your environment variable like this. You specify it in a file, and you commit that file into your server. No, you don't publish it to a public repository. You copy it directly into the server. So because you don't want people to have access to your database. So let's try to run it now. So the application is starting. Fingers crossed. Yes. Yes, Docker is running. Yes. So our application is up and running. And we can test this because I put a route to show hello route. Okay, let's just. So it means our backend application is running in a container perfectly. So thank you very much for this assistance. Yes, we should clap. So the next thing after our backend, who can tell me what the next thing is? We have deployed our database, we've deployed our backend application. Okay. We've run our backend. So what is the next thing you feel we should? Front end. Thank you very much. So I don't know if there are any questions at this point in time. Also from people online, if you have questions, please kindly ask. So we move on. So the next thing we try to run is the front end application. Though we've had a test of it before. So there are two ways we could run the application. Well, in both ways, we need a server. We could run it in development mode, or we could run it in a production mode. So if we are using a production mode, we have to put in a web server. So that's why we have the nginx directory here, which is the web server that we will use to serve our application. So here we see the Docker file for when we want to run it in a production mode. So we specify, at least who can tell me the basic image of this Docker file? It's very simple now. Yeah. So that as is specifying a face, you can have different faces in your Docker file in case you want to merge two images into one. So who can tell me the working directory in this Docker file? /app, thank you. Who can tell me the port that is exposed in this Docker file? Port 3000, thank you. So this is the first phase. Specifying the base image, specifying the working directory, copying the package.json into the /app directory, installing all dependency, and building the project. Now this builds the project, but how do we save it to the users? That's where nginx comes in. So we specify the base image as nginx. We expose the port 3000 on it, and we copy the config file. So we have the config file, yeah, default.conf. So this is the config file, copying it into the etc directory of nginx. Then this copy, we're specifying copy from the builder phase. So copy from the output of this phase, copy it into the directory where nginx, which is a web server, serves its files from. So that is the whole description of this Docker file. So what we do here is try to build on the image. So because of time, I'm just going to do it myself. So Docker build, specify the name and the context. Oh, there is an error. And who can tell me why the error came up? Thank you very much. Because I'm not in the front end folder, it gives an error. Though there's another way we can run it without being in the front end. You specify the -f flag and we specify the path to the Docker file. So this tries to build the image. So while the image is building, let's look at the run command. So this one is rather simple. It needs no environment variable. All you just need to do is to specify the name of the container, the network, we publish the port, and the name of the image. Very simple. So this is the config file of nginx. So it listens on port 3000 here. That's why I specify port 3000 here. So does anyone have any questions so far? Also from the theoretical part.
Brother.
Okay, it's done. Colon 4,000. So we can see the command here, docker run first the name of the container, the /rm flag to remove it in case of when we stop it. We are publishing the port on port 3000 local system. NGINX is listening on port 3000. We are specifying the network and we are specifying the image. So, but before we go on, how does the front end is supposed to make API requests to the back end, and this is in a network, so we have to ensure we specify the right host name for the front end. So we go into our application and we check where it specifies. Okay, we're not using the network here, we're using NGINX. Let's leave it like this. Or we could also specify the host name, but we can leave it like this. So now we run the image. Port is already allocated. I think the first one, any name, is still running. So this one, map to port 3000. So we have to delete this container. Who can tell me how to remove a container? The command. Thank you very much. So done. So now we have our front-end application running. And since we publish it on port 3000, we can also check it out. So we can see the front-end application is running. But this is not the way we plan to run it on our slides. We plan to serve it through our default web server, which routes traffic to either the backend based on its configuration, or route it to the front end based on its configuration. So we'll be starting an NGINX service now. So before we go there, let's check the Docker file. So all this Docker file does is to copy the configuration into the etc nginx confd folder file. So we can see here, this is the configuration for nginx. So this is the host name we specified. This is the name we specified for the container. And this is the name for the front-end container. And this is the name we specified for the back-end container. So Docker checks, based on the network you create, Docker checks this host name and automatically routes traffic to um, to this IPA based on the network. So all this thing is done for us behind the scenes by Docker. So the server is to listen on port 80. So the first thing we have to do is to build the image. Okay, the same mistake as before. Is anyone trying this out with me? I'll be happy if someone is trying it out. So we can duplicate this result on another system. So now we want to create and start the container. So let's go through the commands again. This specifies the name of the container. This specifies remove the image when I stop it. This specifies the network. And this publishes the port. It means this is the container port, this is the application host port. So when we want to visit the application, we use 8080. And this is the name of the image. So now let's go to localhost 8080. Page not working. What might be the... Okay, you can see an error here. It says upstream tax management API not found. So I guess we made a mistake in the name. So to be sure, let's look at the name of the container of our backend with Docker PS. So the name is tax MGMT. So in our configuration, we named it MGT. So that's why it failed. So we have to rebuild the image, change the name, and rebuild the image. So let me just copy it from here to avoid further errors. I can't see. Where is, okay. No. Okay. just copy it. So now we have to rebuild the image and rerun it. So let's see if it will give any errors. So no errors. So your application run now. So you are running each services now, all in containers. Each service, the backend, the front end, the database, and the web server, all in containers. So we've made no change. Even on this system, I don't have PostgreSDB installed. So I'm able to run a PostgreSDB database using containers. So these are the advantages of containers. So it helps us to spin up application very easily. We can easily create it. We can easily destroy it. So let's say I want to deploy my application on AWS or Google Cloud platform, or even on my own, or maybe probably an HPC you deployed. I just need to find a way to push it to a public repository and pull it from my HPC into the server. You can use applications like Travis CI and Jenkins and what have you. These are CI/CD tools, and to automate everything for you. Pull it, or you just need to put it to a public repository like GitHub. So you should take the code, pull it to your server. You specify the host name of your server, pull it to your server and execute it, and start the whole process for you. So all this is possible because of containers. Containers make it easy to start an application, stop it, restart it, whatever you like to do with it. So let's test the application to see if it's working. So the first thing we sign up. So the sign up works, thank God. So we sign in. I've already saved the password. So we sign in. So we're into the application now. So this application is to create tags. So this application is not perfect. I got it from a repository online. So if it has bugs, please take it easy on me. So we see the tags here. So we can create numerous tags and update it, change, okay, I'm done with the tags. I can delete it, I can log out. All done based on containers. I don't even have some tools installed on my system. All achieved through containers. But can anybody give me one challenge they noticed from building this application the way we built it? There was something that was kind of annoying. I don't know if anybody noticed it too. Anyone? I think running these commands for me were very cumbersome, having to copy and paste it. For example, you saw the mistake I made in the backend name. Having to make those mistakes is kind of annoying. So let's say I have a service that has 50, I have an application that has 50 services, and I make mistake in 5 of them. It could be very, very frustrating because it will be hard to find where the mistake is coming from. So this gives a lot of headache, and that is what Docker noticed and created a tool called Docker Compose. So now everything we have been doing, this is it. I've pasted it on the slide. So we first have to create networks. You can see how long this command is. Just to start a database container, you can see how long it is. Then the backend application, we had to first build it, then run the container, then the front end and the web server. So if you have to do this for 70 services, this is very, very, very long and complicated, and it's not productive at all. So is there a better way we can do this? And that is where Docker Compose. So as I said, the challenges with Docker is that the more configuration setup a service needs or a container needs, the harder it becomes to manage. So for example, the backend service, we had to specify several environment variables. If it's a very large service and you need to specify 50 environment variables, it becomes very cumbersome and very, very long to specify all those environment variables on the terminal. So another challenge is that the more services you have, the more complex it is to set up a full stack application. This can lead to multiple errors, less productivity, and more time debugging. So Docker Compose is a tool for defining and running multiple services by replacing Docker build, Docker create, Docker run commands with just one single configuration file and a set of orchestration commands. So next we'll be seeing a Docker Compose configuration file. So Docker Compose uses YAML. I think we all learned about YAML in the previous classes. The name is yet another markup language and uses indentation as a way. Is a markup language based on indentation to define its files. So the first thing you state is the compose version you want to use. Then the next thing you state is all the services. So you have to ensure of the indentation, else it will give you an error. So you mention all the services. In our application, we use 4 different services: PostgreSDB, our backend API, our front-end API, and our NGINX server. So these are all the services we need. So instead of having multiple Docker build, Docker run, Docker create, and all these commands, you can just specify everything in this configuration file, and Docker Compose will pick it, create it. We even create a network for us that we had to create manually. Create a network, create all our volumes for us, and get our application up and running just by specifying everything in your configuration file. So we see the first service, our database. We specify the image, PostgreSDB. We specify that if it fails, if it crashes at any time, it should always restart. We specify the volume that it saves its data in. We specify all the environment variables. You can see how easy it is to specify environment variables in a Docker Compose file. And if you want to use a file rather than specifying it here, because this is not advisable in a production application, you can't just show your password like this to the world. You put it in a file and you copy that file directly to your server, and Docker Compose will pick. So this is the way you specify env file and the path to the file. So the next service we define, you notice the indentation. They are both on this. This is line 1. This is also line 1. So now this, we are building our own image. So it's not like this where we are using an image from Docker Hub. And we specify the Docker file, specify the context. Context is where the Docker file and all the programming files you need to use are, and they are in the backend folder. Specify all the volumes they're using. You can see how easy it is to specify environment variables in this case. The one good thing is that you can specify what services this service depends on. So before, we had to make sure we created the database before we created the backend application. So here, Docker Compose will ensure that this service is not created before the Progress DB. So this is done with the depends on key. So here we are defining the service for the front end. And you can see the indentation is very, very important. Specifying how it builds the image, all the volumes it needs, environment variables, and we are telling it don't build the front end if the backend is not yet created. So the final one is the web server. And this is also very important. If your web server crashes, you need to restart it. So that is what the first command is for. Then we don't want the web server started if our major services are not yet up and running. So we specify, okay, the backend should be up first and the front end. So don't create the service if these two services are not yet created. Then we put the build command, how it should be, the image should be built, and the ports to create. So in a Docker compose file, you have to specify the volumes underneath, your named volumes only underneath. So that's why this is here. So we have a named volume in the Postgres DB service. We can see it here. Mount. So these are the commands Docker Compose is used. So rather than running over 8 commands, we can just use one command now, Docker Compose up, and it starts all the services for us. If you wanted to rebuild images, Docker Compose up, build, Docker Compose down, Docker Compose down v means delete all volumes. So yeah, we can try this now to rerun our web server, our web application with Docker Compose. I don't know if anyone has any question on Docker Compose. It's just a configuration file where you list all your services, so you don't have to be executing each one by one. You specify everything you need to execute the services in your configuration file, your Docker Compose configuration file. And yeah, so this is how you name it, Docker-compose.yml. So we move to practical now. So what we just ran now, we try to run it with Docker Compose. So everything is listed in your Compose directory. All the files are listed in your Compose directory. If you want to follow along with me. You go into the Compose directory. The backend, the front end, and the Nginx is listed. And this is the configuration file for everything. So we try to run this now. But first, let me stop all the other running services. So to stop a container or to remove a container, use the Docker rm -f flag and the container ID. So this removes the container. So we just removed the Nginx container. Yes. So to check all running containers, you type docker ps. Now I'm using the container name. So we've deleted all the containers we have from the previous practical. So now we are going into the compose folder. So I just showed you guys how you configure a compose file. PostgreSDB, task management, front end, and the Nginx. So to start it, you just specify docker compose up. I hope I'm correct. Yep. So this, you can see, is creating a network here. So it creates all the services for us without any hassle. Very, very easy compared to the former mode we're using. So Docker Compose does everything and it orchestrates everything for us easily. So the PostgreSDB is up. So our backend application is up. You can see how easy this is. I don't need to be copying and pasting commands. If I just make one mistake in I omit one letter, it's already a problem. But with this, everything is already defined in a configuration file. So let's wait for others to come up. Okay, the front end is up. Let me see if Nginx is up. So all our services are up now. Just with one command. Feel that's powerful. So let's see Docker PS. So we can see our web server is on, up, compose Nginx. Our front end is up, our back end is up, and our database is up. So let's test it out if it works again. So it works. Let me close this. Yeah, I deleted everything we created. So our running application is up again, all powered by Docker Compose. So let's say we want to delete all the, I had to do it one by one to delete each containers. Let's say we want to delete everything. It's also very easy. Just one command, as you see in the slide, Docker Compose down. So this removes all the containers easily. So first I have to, this stops it but doesn't delete. So with one command I can stop everything. But to delete all the container, just do Docker Compose down. And this removes everything just with one command. So it makes life very easy for developers. I don't have to do Docker PS, start checking, okay, what is the container name of container ID of this container. So that's the advantage Compose has over your manual Docker. I don't know if anyone has questions at this point. Any questions? So let's just try I think we've tried it already, so it's the same application I tried before. Exactly the same thing. I'm creating it again. Yep. Composing, I like that one. Composing it again. So if you remember, on the first day, I was saying something about bash aliases. How you can use it to shorten commands. So here we have a lot of commands, and Docker build, FNT, Docker push. Though we didn't get to Docker push, Docker run. So you can use bash aliases to shorten it. Though I'm on a Windows machine, PowerShell also has its own bash alias, own type of bash aliases. I can show you. So you can see my bash aliases for Windows PowerShell. So if I want to check all running processes, I can just type docker ps or dps, and it immediately prints all running processes for me. If I want to build a particular image, I just use dbd and I specify 2 arguments, the tag name and the context, and it does it. So rather than typing docker build -c blah blah blah, if I want to build and push to a public repository, I can easily do this. So we have so many of them like that. So it's just to make you much more productive. So the actually the command I used to start this code editor is also an alias psprof. So it opens my code editor for me. So let's check running process with my bash or my PowerShell alias. Doesn't work. Oh no. DP. Okay. So it works. I made a mistake in the spelling. So DPS. So you can also learn how to create bash aliases for PowerShell. Very easy. So let's try the application now. First, let's try to sign up. So sign up works. Or let me sign up with another account. Name it. Okay, this is sign in. I have to sign up. I said this application has issues. It's not perfect. Yeah, so it works now. So it's different account name. So you can see the password might have one uppercase, lowercase, and a special character. So I've been able to sign up. This is supposed to show some logs. Okay. The NGINX has taken over the logs. So let's sign in now. So signing was successful. And create any tax. So this is why I say it has issues. Yeah. So the application has some issues somewhere. Okay. I used a different user. Yeah. So the two tags are available. So I can update the and also delete and log out. You can see my tags. So all this is being powered through Docker Compose. All this application, the database, the front end, the back end, the web server, all this is being run via Docker Compose. So just with one single command, we can start all our services. So if you have 300 services, all you need to do is specify it in your configuration file and type Docker Compose up, and all of them will be started. You can also specify some orchestration command, like which will come first, which will come last. That's why you see it depends on key in the YAML file. So I know we have to close by 4 o'clock. So the other part of this, because it's supposed to start next, please give me a moment to ask some questions.